And let me share my screen here. So I ended up posting, and I'm not going to sort of review that video. So for the JavaScript content I posted, I'll sort of let that stand on its own. And I'll, after we go through the Python homework, I'll kind of, use this time rather than going into new content, just kind of answering questions and talking overall about how how I'm planning on presenting this JavaScript content. So starting out at the Python homework, and in terms of grading, I think everyone should, aside from one or two who there were some quirks, but most people should have their work back. So I'm a bit caught up with grading. Are there any questions about the Python homework before I get started? Any comments so far on switching from R to Python? Like I know in terms of what you guys have been exposed to, it's more R than Python. Did you find that it was uh, big learning curve? Have you, has it sort of colored like what you think of Python? So perhaps in the future you may want to continue working with it or just kind of convince you to stick with R? Yep, I have a few comments here saying that it's different than R, and some people prefer R to for its ease of use. And yeah, that's absolutely correct about Pandas. That Pandas is a really powerful library. I think it's one of the real benefits of something like Python, and kind of the theme that that I'm seeing on what you guys sort of are posting here is, sort of thinking of R for more data analytics for kind of as you go forward and get into the more math oriented courses, a lot of those will be based in R as well. And it's just nice to have something like Python in your tool belt, first of all, because there are, being a general purpose language, there's just a lot more that it could do and like Python could do in general. And it sometimes helps to be in that larger ecosystem. So things like, at least personally, like if I'm doing sort of more modeling, like I would probably stick with R. But if it's kind of what I'm doing is a bit more on the data engineering side. Just personally, I've been I've been more sort of ingrained with Pandas, so it's I sort of almost think of Python as more the data engineering side, and for sort of heavier analytics. But I'm glad everyone has sort of, you have this basis of comparison now. And looking over everyone's homeworks, it seems like everyone was also getting a really good handle on the notebook environment. There were one or two people who chose to submit in just sort of Python scripts, but mostly it was sort of utilizing the notebook format, which it is different than RStudio, so it does take some getting used to. In some ways, in some ways it's better. In some ways, it's worse. Personally, like I think it's a nice kind of like I personally like this better than in R if you're using R Markdown. But it's a nice, just good to sort of have this as in as sort of an explore. Like in a lot of comments, I've been mentioning that like a lot of people seem to have gotten the exploratory powers of a notebook, being able to kind of run through your research in almost a linear storytelling kind of way. And I caught that from a lot of the homework, so that's a good thing, I thought. So with that, we'll get into the homework. So I and I realized on the assignment I forgot to update it with a couple of the um, other packages. Some people did use Plotly, but but a lot of people used sort of Pandas, Seaborn, a lot of the other um, packages, and kind of use a bouquet and used a lot of them in addition uh, to sort of matplotlib and kind of testing out the packages there. In terms of people on the call, were there any favorites out of what you guys tried? Yep, lots of people chose Seaborn, and Seaborn is a great, statistically minded visualization package. Yep. It's meant to be so the like part of what I've been trying to do is like sort of rather than just use like ggplot, sort of expose you to the different types of libraries, visualization libraries in these languages. Like for R, ggplot is sort of the big hegemon, but in Python it's a bit more of a kind of distribution. And this is in reference to a comment in the chat about how Seaborn is lightweight, and um, you could kind of think of a spectrum that all of these packages are on, where you have something like Matplotlib. Plotly is a bit more user friendly, but still kind of on the sort of more uh, kind of defining the figure sort of style of visualization. Whereas you have tools like VegaLite, ggplot, which are more about more data centric, and you could also put pandas in the in that category. And yeah, bokeh, it's meant to be fully interactive. There was actually a particular feature some people used where I knew it had some inline capabilities, and I knew that it was able to sort of pop out the sort of HTML version of the graph. But some people sort of utilized more advanced formatting within bokeh, which was really cool. So the with some versions of bokeh, with bokeh, you have the option of, if you have a complex visualization, kind of creating that using bokeh. So not so much, it doesn't so much get into something like Shiny, but it allows you to kind of, format a page, control your faceting, add tabs, which some people took advantage of. So so that's definitely, I'm glad people were taking advantage of that. And in general, like this is, like the interactive plots I have here are from Plotly. So in my example, I didn't use Bouquet, but the uh, but Plotly and Bouquet, like you could kind of think of them as really taking advantage of a major strength of notebooks, which is they are HTML based, and it's oriented towards display. So it works with RStudio where you have an HTML viewer, but it you kind of have a bit of an expansion of what you're able to do when you have an output that is able to be HTML, and you could kind of plot using these interactive plotting libraries. I don't think I posted this someplace in the course materials yet, and I may just include a link. Uh, this is an open source project called Interact, which it's meant to sort of move notebooks. First of all, move it to a desktop-based environment to kind of lower the barrier of entry for people using notebooks, and it also kind of is, with notebooks, you sort of start with using like the PyLab magic. So you're displaying matplotlib with it inline, and then with more advanced visualization libraries like Plotly and Bokeh, you're actually showing HTML. And with interact, you're actually getting a bit further where it begins noticing the data types that you have and kind of displaying relevant plots. So it's integrated with Plotly, it's integrated with Leaflet. Like you could copy and paste a JSON file, and when you view it, it automatically ties it in with Leaflet. So it's really cool for that just in terms of where these sorts of technologies are heading. Like this, I think is going to be a sort of getting more sophisticated with what you're able to show in these notebooks is a major direction I see this technology moving. But with that, we'll get through the homework here. And in terms of these visualizations, the majority of you guys got the what the questions were asking in terms of like graph wise, like what kinds of graphs to use. There were a few here or there were a few issues, but mainly it was you guys sort of understood that, and it was really about kind of learning the technology of something like the notebook. So here for the first question, first just sort of bringing in the data and looking at it. So part of the assignment was data cleaning. So it was kind of a messy data set, and there are some sort of just outright quirks that you can't you can't have your numeric values for an entero count without doing some massaging. But there are also some just data issues that make you question like how this is being collected, and that was part of the assignment, which a lot of you guys were got. So pretty much everyone was you had different ways of dealing with these issues. So here, looking at the just describing the data set, we could see when we do have numeric variables what some summary stats are. And this was sort of mentioned in the practice, but one of the first things that you notice is entero count is not there. This is really the main measure that we're looking at, and for some reason, it's not showing up as a value as something that could be summarized in this way. So first, and also the date you could see is being first interpreted as a string. So first thing that we'll do, we'll just take care of the date. So I'm just translating this using the apply methodology with pandas. In terms of just kind of this style of data munging, were there any real pain points aside from, I mean, there's always going to be some sort of, you're sort of switching context from R data frames to pandas. Indexes mean more, that's just sort of the style of the library. But were there any major issues that people had, like things that were just very annoying? Cool. So it looks like the cleaning was fairly straightforward. There are a couple ways of working with things. Like Pandas has a lot of built-in functions, and one thing to that even when I'm using it, I still have to sometimes remember when this makes sense and when it doesn't. But with Pandas, it's less automatic than R is about kind of vectorizing your functions. So a lot of times with R, it's very good at, you throw a column of a data frame into a function, and it knows you want to, sort of apply that function across for each sort of row. And obviously R has its own methods of like split, apply, combine, which is, sort of you divide, you do some sort of group by summary statistics. But with Pandas, you sometimes have to think about like, how are you applying this function? And like, if you just sort of apply a mean, it's going to give you the mean of the entire column. So there's some things that you have to keep in mind there. Mean was a horrible example. but you guys sort of understand what I uh, hopefully understand what I'm getting at there. Um, Yeah, so in terms of data transformation, the dplyr pipeline, I mean, partially it's we're all more used to that. Partially, it's in my opinion, it's kind of a more straightforward way to deal with things. With Pandas, it's really good at like Pandas is created by I think it's AQR Capital, so it's very time series oriented. The um, like indexes are very important, so it really helps when you're dealing with time series data and when indexes matter a bit more. Like I found that it's really good at sort of working with multiple data frames where you need to match indices. Um, so that's just a bit about pandas there. Um, so when we're looking at what's happening with Entero count, we could see just by looking at some counts of values, we have some of these weird strings showing up here. So there's less than 10, less than 1, greater than 2420, and greater than 24,196, which is pretty dirty. And for some of these, it's kind of easy to think about how to deal with them, but for others, it's tricky. So for less than 10, something like well less than 1 and greater than 24,000, those are the easier ones to deal with because those are kind of your caps. So you could replace them with 0, or I just kept the upper limit at 24,000, which I saw a lot of people did as well. um, but then you have things like um, what does it mean to be greater than 2400? So, there's probably some issues with data collection that we could get into, but or that doing more research on where this data is coming from, like we could try to find out. But just just in terms of the data on its own, like that's a harder bound to deal with because we don't know whether to replace these with just 2420. Do we replace them with something closer to 24,000? So it's kind of difficult there. And so what we could do is just look at a couple of sort of look at the distribution of these higher counts. So I could look at some of these outliers which are greater than 2420 and just get an idea of what they look like. So, so here you could see kind of, this is the total, I think, and then where's, actually this might not be the total. So basically, what this should be showing, for some reason I'm not seeing that, is like it's mainly these are clustered around around 3,000 to 5,000 when you're looking at the values. So basically, we're some people just wrote 2,500 or 24 something for higher values. So we could just kind of here I'm using kind of a rough rule of just putting in 3,750, and we'll see when we're plotting out what that looks like. So when we're looking at our total scatter plots just of date and Entero counts, you could begin seeing some of this striation. So it's not too bad. And there are a couple of ways of, like, for less than 10, um, I'm using random numbers here. And you could, there are strategies of, like, you could find out what the underlying distribution is and match them in that way. But for greater than 2420, we'll just replace those with this arbitrary number that we're using. So now we have our data. These are just kind of our broad summary counts, so we could get a broad idea of what our testing is. So we have most clustered below, sort of in this below 2000 range, and then you have a couple of peak days. So you do have those outliers. And these are just a couple of different ways of plotting it. So this is using pandas, which is just accessed directly from the data frame. And there's also Seaborn. So this is bringing, or actually, no, this is doing the same thing with pandas. I got Seaborn below. So the first question was, there were a couple ways of answering it, and I didn't really focus. Like I left it open, so I didn't, I didn't think it was fair to ding people on like how they chose sort of the best and worst places to swim. But if you are thinking about like these sorts of measures, it's not a straightforward question what this could mean. If you're just quite a few people would look at just the mean and kind of use that as you want to look for lower mean interro counts, but the distribution matters heavily there. So if there's if there's a beach where it just had one really bad day and people were properly notified and the rest of the days are good, that's a safer beach than a beach where it's kind of it just has a larger quantity of rough days, but not as rough a day as the clear place had. So the distribution definitely matters. And one thing that you're able to use is kind of a cutoff of when is it safe, when is it not safe, and taking and sort of creating a percentage of safe versus unsafe days. So there were quite a few people who picked a method like that, and that's what I'm doing here. So I'm looking at I'm essentially having this pass safety here, and I'm grouping by here I'm getting a site pass rate. So we're grouping it by site over here, and we're getting sort of the mean of a particular slice here. So here you could see these are the worst sites based on these pass safety measures. So you can see we have some pretty low measures here. And then we have the best. So this is another good thing about notebooks in general and about sort of Jupyter notebooks is it's very good at just kind of inspecting your data and being able to kind of display lists like this in such a way that other people reading it would be able to kind of follow your train of thought. So in something like our studio, you have you're able to inspect your environment. You could look at your data frame. You could just simply look at the head of the data frame. But this kind of lets you almost in a reproducible way kind of explain what you were thinking, explain what you've looked at, and just not really think about the display of a lot of these. So that's kind of what I wanted to get at when I mentioned it's lists and graphs, and everyone is really using that in a good way. So I was happy with that. And yeah, and then we have sort of the low, the best and worst sites here. So here are the best, right? And we could sort of graph these in a few different ways. So we could graph them just by their here. And basically, this data munching here, what I'm doing is taking those best and worst sites and then filtering the main data set based off of that. So here we're just getting this worst readings and best readings. We have the sites, but this isn't giving us. This is aggregated information, and we want and we want to be able to sort of with those best and worst sites look at what's going on with them. So that's really what I'm doing here. You could see, again, the heads of both of these data sets. And then using Seaborn, it's fairly straightforward to like Seaborn has really good support for faceting. So you could take a data set like this where it's divided by site and facet by site, so you could make quick comparisons. So that's what we're doing here, where we're bringing in the data and we're we're sort of adding a separate facet by. So that's what you could see here. And these are just looking at the best sites and kind of analyzing over time what their tests were. Or I'm sorry, these are the worst. Gowanus Canal, definitely not the best. So here you could see the worst, and then as an example, and then I ended up using Plotly as another example of something like that. So this is to sort of show how there are when you are making a graph like this, like there are lots of according to the package that you're using, there could be pretty drastic different ways of doing things. So with Plotly, it's when we're actually working on getting a more intuitive faceting feature. So it is coming, but at the moment, it's sort of you're building with subplots, and that's good because in defining subplots in this way, you're able to like the way that I would describe it is you're sort of using Plotly to define the graph rather than kind of letting the data sort of automatically define the graph, which is what a lot of these like Seaborn, ggplot, like a lot of these more sort of grammar of graphics based packages work. And it's good when you're like really fine tuning something, but sometimes you just want to facet by rather than defining something in another way. And the one thing that I'll sort of mention here is I did some fancy iterating here. If you guys haven't run into iter tools, that's a pretty cool tool. So here, like I'm just sort of using information in multiple things that I'm iterating through to build my traces up. But once I do that, like you're able to get sort of something that's interactive and in line. So we have just sort of checking out what's going on within these areas. So you could see kind of what is causing it. So surprisingly, something like something like Gowanus or the Sawmill, you could see they have a couple of outliers that are causing. They have sort of a distribution of good scores and then sort of a couple of very high scores, whereas a couple of very high scores, whereas and actually that's probably not true. These are probably just very high because if I zoom in here, you can see that these will be around the 4,000 there. So similarly, I did this just by showing the sort of passing rates of the sort of best and worst sites. So here you could look at the worst and look at the best using either Plotly or Seaborn. So at the best, you could see that we had some places where it was always passing, or all the best places where it was all passing. Cool. So if anyone has any questions, just put on the chat. But otherwise, I'll just continue. And the second question, this was and most people like understood what was sort of what what to look for here, but basically this was similar to the the questions in the first homework, where we're looking at a distribution, and part of the, in homework one, it was like box plot or some form of a scatter plot. Those were sort of the best ways of dealing with it. So here it was sort of a similar question where it's there are ways of there are ways of analyzing the sort of long stretches of days um, between tests, but one of the best ways to just visualize something like this is towards the bottom, is just simply using a scatter plot. Like when in doubt, just look at that, and you could kind of get a rough idea um, of what you're looking at. So here you could kind of see what's going on. You sort of have uh, a lot of these testings that are months apart, and you could see that pattern pretty clearly. And then you could see these sorts of long stretches where nothing's happening, and you could, most of the time that's referring to the winter. So you could imagine that when the water is frozen over, when no one's swimming, it's less of a concern. I mean, when it's frozen, you don't really have a concept of if it's frozen. I don't think the bacteria would even be able to survive. Um, but so that's sort of and a lot of people had really nice versions of something like this. So either looking at a lot of people use scatter plots, which were perfectly um, which sort of showed perfectly like what the different frequencies were. And a lot of people, some people used heat maps, which also had, it's really good for this almost tabular data where you have sort of a categorical y-axis. It looks really nice with that sort of, with a heat map. And all of this, like what I went through here, is just some kind of analysis of these days between samples. So when you're looking at a histogram of days between samples, you could see a lot of these are around a month, and you have sort of another cluster around every 7 months. So that's places that are likely to freeze. So here, this is just getting into into that analysis of different testing sites and seeing what was happening there. But a lot of people did really good with finding ways to display this sort of information. And then lastly, for the third question, a lot of people, again, this was pretty straightforward. A lot of people had really nice visualizations for this, where we were looking at, this is pretty much a scatter plot question. So a lot of people went with something that's similar to what I have here, where you look at these different sites and you're sort of mapping out the line of best fit. So here I'm just using Seaborn to do that. So any more questions on Python before and on this homework before we move on to JavaScript? One more thing to mention, actually, on Python, I posted. I use this as one of the discussion topics, and it's whoop, that's not what I wanted. There we go. And I mentioned that I'll post a couple of links for Dash because this is now in beta. So if there are people who are comfortable in Python and want to use sort of a Python Plotly combination for their final project, then something like Dash is now sort of in a more stable than it was before beta release. But it is still in development, so it is still getting sort of beta releases that may result in some code change. So it's hopefully by next semester this will be ready, because this is a really nice tool to sort of use as a Python version of Shiny. But I'll post links to something like Dash, because this could be really good for your final projects. And actually, on that note as well, on final projects, so I'll talk about that before I get into JavaScript. I got back. I should have gotten back everyone's submissions everyone who put them in. They're really great ideas. There were some that required just further fleshing out, and the for those who need like more of this fleshed out, I sort of put a next steps sort of comment. So if you guys have one of those, then I'm sort of expecting an email from you. So sort of email me with sort of just clarifying what it is that you're working on and including a bit more detail. What I like mainly what I was looking for was, obviously you didn't have to have like work done on the project, but I wanted, I just wanted if you've located the data set, but didn't really have, sort of an idea of like what sorts of relationships they were looking at, what their goal was, and it was more kind of at the point where which is a valid point, like when you're working on projects like this, sometimes you first start out at checking out a data set that happens to interest you and exploring it, seeing if anything jumps out at you. And that's great for sort of, before the proposal, but, sort of at kind of, what I was looking for was more kind of having a goal in mind of, I looked at this data. These are the sorts of relationships that I'm looking for. I've checked to make sure that it's complete. So there's sometimes if you have a data set, you may not realize until you really begin exploring it that there are serious issues with it. So that's just something to keep in mind. Those of you who have those comments, just sort of write me a new email about the proposal. And yeah, so email is the way to go there. I'll put out an announcement of that now that I'm done with grading those. Yes, yeah, Dash is we're excited about it here. It's like what I like about it is it's built on top because Python is more of a general purpose programming language. It's built on Flask, so it kind of takes advantage of a lot of the sort of Flask language. So things like callbacks, like these decorator functions. But I'll post these links. It's pretty cool. I was kind of purposefully not showing it off too much because, like I mentioned, it is still in development, and I didn't want anyone getting messed up with, when our product officer decides to send an update to it that breaks a couple of syntax. So but hopefully, like now it's in a pretty stable situation. So if you do want to try it out for the final project, feel free to. And it is a really cool framework. And another issue that I'll get into when I begin talking about how we're looking at JavaScript is a lot of people. There were a lot of people who had who wanted to have a geographic sort of, they want to provide like have maps as part of their visualization. We don't really cover that as part of of the course. So I'll go through a couple of tools that will make it easier. Based on what I've seen, I don't think it seems like a lot of choropleths. So uh, with choropleths, there are other ways of working with it. There's and actually, it may just be I don't know how to use Cardo for choropleth, so I may have to look up look up some of that information. But this is an example of something of sort of a web service in a similar vein to Plotly, where it's a JavaScript library. Cardo, in addition, has connections to PostGIS, which is PostgreSQL's geographic component, and it so these kind of make that whole development experience easier to manage. Um, and in this over here, and I should have brought this up uh, before, so I'll have to look up what exactly. I'll just show you an example of things that you could do with CardoDB. So here I have query test. So let's just get that. So something like CardoDB, you could use it in like as a base JavaScript language and kind of have your own. So actually, let me take a step back. Services like Cardo, like Plotly, they have like pretty heavy, GUI interfaces. So you're able to just sort of upload a spreadsheet and work with the data within web-based systems. So if like with Plotly, for example, if you want to use Plotly for your like if you wanted to use Plotly, you could use it as a non-programmer, just sort of building a chart using the workspace. You're with services like these, you are like with Plotly, all of these graphs are like at their core JSON objects. So um, feel free to use this as kind of an assistance to like if you need to figure out the syntax to something and you want to just sort of look it up in sort of a workspace environment. But um, basically like for this class, like this is looking at more, you guys are more advanced. So Plotly has things like dashboards. With Cardo, you're able to sort of build a map entirely by the GUI and then just sort of share a link like that. That's not really what the class is about. It's about more kind of, really getting under the hood and building something. So um, with with Plotly, the way that you could see something like this, and I'll post about this more when I begin getting into services like this. But you have graphs that are saved, and with graphs like these, you could add them to dashboards. You could do things like that. But really, we're going to be sort of concerned with the JavaScript behind this. Like for your final project, if you are using Plotly.js, you would need to have a standalone sort of HTML, a standalone JavaScript that's building these graphs in Plotly. And that you could sort of begin to see over here. So this is just kind of the intro to how to build Plotly graphs with JSON, or with JavaScript. So here you could see kind of what the layout looks like. If anyone used Plotly in Python, you'll notice it's very similar. It's just dictionaries replacing JSON. But this gives some pretty nice examples of how to sort of build a graph. But it goes beyond because Plotly is a full JavaScript package, you're able to do what you're able to kind of do anything that you're able to do in JavaScript and take advantage of Plotly's interactivity. So, and this is similar to D3, although it's more it's harder to do in an environment like D3. But so the way that you could look at this, and I believe it's, there it is. So, and this is what I'll post when I get into intermediate JavaScript, which is sort of handling events. You sort of saw it in the intro, in sort of the intro JavaScript, where you have a, here you could sort of see that you have some sort of input. So here, let's actually do this. So we'll get some practice looking at how this works. So I go through in the intro video that when you're looking at these, when you're looking at JavaScript, you need to kind of stand your own server, and kind of made the comparison to Shiny, where with Shiny, that's all taken care of for you, but there is, and it forces you to think that way with the server and UI side, but you're not thinking, you're running the server through RStudio essentially. Whereas with web development, with JavaScript, you need to manually set up your own server, and you have an HTML page. That HTML page is referencing JavaScript. So we'll get in here. And what I'll do is just this is the easiest way to get a server. It's just Python simple HTTP server. And we'll start that up. I'll try to enlarge this a bit. So first what I did was just run a server. So now when I go to localhost, has everyone on the call taken a look at that JavaScript video? Cool. Cool. So this should look a bit familiar, where you stand up that server, you're going to localhost, and you get to view your web app here. So this is very simple, where it's just doing some simple math. But what I'm going to go through in the next portion is delve into really what's happening here. So you're taking that input. So is a number odd. So here you have that, is a number odd or is it divisible by 3? You have a function that it's tied to. So either calculating or calculating if it's divisible by 3, I think. And when you run that button, when you have that button, so you have an input type button, which is this, and like it's all part of one form object. So you have your input, you have your button, and you're essentially saying, when I click this button, I want to perform a calculation. And what I'll get into is sort of how you could define these alerts. And obviously, like, you could get very very sophisticated with these sorts of things. So depending on what you're looking at, you may need to delve deeper into things like actually defining event listeners. But really, what I would say you're looking out for are things that kind of look similar to this. So like on click, on hover, those are really how you're managing events. And with something like Plotly, you have the, and I'll go into this in more detail in the video, but you have things like where you have your element. So that's, I went through in the first video where you have this get element by ID, and that's your plot. And you're saying my plot on Plotly click. So that's a specific Plotly function, a Plotly event listener that's saying whenever there's a Plotly click, I'm going to perform a function, and you define what that function is here. So it's this anonymous function, and all it's saying is it's just alerting that you've clicked on this Plotly chart. And the so essentially, like when an event happens, there's data associated with that event. So with a Plotly graph, there's like the XY, there's different elements of sort of what trace you're on, and you could perform functions based on those traces. So in that way, if you're using JavaScript, you're able to really sort of have your graph not only as something that's controlled by sort of drop downs or buttons, but you could have your graph kind of be an input layer itself. That works really nicely with Dash. So like with Dash, that kind of abstracts it in Python. And that's also kind of what first brought me to this whole tangent was what you're doing in something like Carto. So here, like this is reacting to 2 clicks on these are subway stops, and it's reacting to what something is like. Essentially, what this is doing, this is actually looking at green taxi cabs that are coming into different subway stops. But really, like from an app standpoint, it's taking in, it's saying like I'm clicking on this, like I have a full data set on the back end. I'm taking in a user's click, and I'm saying like on that click, I'm looking up another data set like based on that input. So so going back to what I mentioned originally, like when you're working with services like these, you're sort of the goal is to use the JavaScript behind it when you're doing it. It abstracts it like Carto is based on Leaflet, so it's definitely a great alternative for trying to just use raw Leaflet. But it's and you could use the various tools on the site to kind of help you build it. But whatever you're submitting for your final project shouldn't be based off of these services. So I'll get into that a bit more in the pre-recorded videos, and and also in terms of these recorded videos, like you feel free to use the discussion boards or email me directly if there's any questions in terms of these. So if like I've said a couple of times, like all of this is pretty different from what we've been working in, so it's feel free to kind of ask rather than kind of it might be easy to get lost in this section of the course. So that's pretty much it, and we're reaching the end of the hour. Does anyone have any questions? So you guys should have received the feedback from me. The so right now it's the like there's the homework 5, which is sort of the intro to intermediate, kind of beginner. It's the first JavaScript homework assignment, which is either beginner or intermediate, and it's meant to be kind of just a simpler proof of concept. But when we get into homework 6, and I mentioned this for like explicitly on a lot of your comments, is the homework 6 is meant to tie into your final project. So you're using JavaScript to create a visualization from your final project. So for some of you, like there were like some longer term evolution I was looking for in like not kind of for your proposal, but just as like making sure that you're keeping on track to submit something for homework 6. So just keep in mind that like homework 6 is meant to help you in service of that. So consider that sort of beginning to play around with your final project and kind of getting that first step. So, any more questions about like the final project, about the structure of how we're finishing things off? All right, so I'll get this posted as soon as possible. I'll and the this week's discussion should be up, but I didn't post a an announcement yet, so I'll sort of post my weekly intro announcement later today. But thank you so much, and have a good night. All right, take care.